viewers. In the last lecture, we have discussed the interfacing of most popular input devices, the switches and keyboard. Today, we shall discuss the interfacing of the most popular output devices. As I have mentioned that the response of the microprocessor has to be conveyed to the user, and light emitting diodes or LEDs are the most commonly used device for that purpose. So, we shall discuss today the interfacing of light emitting diodes. Obviously, it has to be done through input output ports. Now, light emitting diodes, they shine from clocks and traffic lights, they blink on our car dashboards, they flash on the soles of children's running shoes, they glow from the coffee makers in our kitchens, they tell us that our modems are connecting to our networks, they reassure us that our cell phones are on, they lit up the face of the first personal computer and the first wristwatch with an electronic display. This quote I have taken from a recently published article from IEEE Spectrum, and here it says light emitting diodes have evolved into a $3.5 billion industry. This shows the popularity of light emitting diodes, the widespread use of light emitting diodes. And so question arises, why the LEDs are so popular? What makes it so popular? The question is why. Let us first try to answer this question before we go into the details of interfacing. First of all, we will see that the light emitting diodes are semiconductor devices. It is a semiconductor device. There is no filament which emits light, and as a consequence it has inherited the properties, good properties of semiconductor devices. What are the properties? Very small in size, reliable, very reliable, and cost is low, small size, reliable and low cost, and also low power consumption. These are the advantages of light emitting diodes, and as a consequence, because of these advantages, the light emitting diodes are so widely used. Let us see what do we mean by light emitting diode. It was, as you have seen in this particular particle, it was developed by Holoniak lab. I think about 2 decades back it was developed, and initially it was based on gallium arsenide, and if you sandwich 2 types of gallium arsenide and form a diode. So, this is gallium arsenide, and if you pass current through it by applying some voltage, say you apply positive voltage here and this side you ground, then this particular light emitting diode made of gallium arsenide will emit light initially. The light, so it will emit, it emits photon. So, red lights were emitted by this gallium arsenide. So, the gallium arsenide was used in the first material, as used as the first material to emit light, but in the subsequent years many other new material were developed to develop devices of many colors. For example, here I have shown, this is the red color, original one, then you have the green color, amber color, and nowadays you will find LEDs of so many colors that you will not so many colors in the rainbow on the sky. the number of colors is quite large. So, with the help of this you can make very colorful displays. Question is, how do you use it in your microprocessor and display some information? Obviously, we have to take the help of a port line, say PA0 for the sake of simplicity. It has to be configured in the output mode. Then what you have to do, since this particular port cannot drive the current required for emitting light from the light emitting diode, you have to use some transistor driver. Say we use a transistor driver here. So, this is connected to say plus VCC, and then you have to put a current limiting resistor R. So, R will restrict the current that will pass through the light emitting diode. Then you can put the light emitting diode and ground it. This is how you can interface a light emitting diode to the microprocessor through a port line. How it works? So, whenever this line is say 0, of course, I did not I think you have to put some resistance here, so that the base current is limited. Whenever this is 0, the current will pass, base current will pass, that will lead to collector current, and R will restrict the current through the LED, and this will emit light. And what is the equation for that? Suppose the supply voltage is VCC. Then this light emitting diode had some cut-in voltage like this. If you look at the characteristic, it will be somewhat like this. This is the cut-in voltage, say VE. So, this voltage has to be subtracted VT, and then you have to, there will be some drop across this transistor minus VCE, that you subtract. This voltage is about 0.6 volt, this voltage is about say 0.2 volt, let us assume, and that if you divide that resistor, use the resistor to get the desired current, that this is the current that you have to pass in through this LED, and that current is about say typically it varies from 10 to 20 milliampere. So, you have to choose the current, and accordingly you can find out the resistance. Suppose supply voltage is 5 volt, 5 volt minus 0.6 volt minus 0.2 volt, and then you divide the resistance to get a current of 10 milliampere to 20 milliampere. This is how you can interface one LED to a port line. So, you can use a transistor and two resistors, as you can see. Of course, you can use some integrated circuits also. So, for example, an TTL gate can be used for this purpose, and for that you have to use the, say I would like to interface another LED PA1. So, you can use the inverter, and then this will go to the LED. This is the LED, let us assume. However, it can sink current. So, you have to connect it the other way, and this has to be connected to VCC. As you know, the TTL gates can sink more current than it can source. That is why it is being used in this configuration, so that it can sink the necessary current for emitting light. Obviously, this is the symbol you have to give for light emitting diode, and this is how you can interface by using an inverter, say 7404 inverter. And you can show the state of the microprocessor. So, suppose you want to show that the microprocessor kit is on or off, that you can display with the help of this LED. So, in this case, whenever this is 0, then light is emitted. That means, whenever this is 1, then light will be emitted. Whenever the output is 0, no light will be emitted. So, this is how you can interface a single LED, but single LED is not sufficient, cannot convey much information except on, off, like that. So, you have to convey much more information, and for that purpose you have to use 7 segment LED displays. The 7 segment LED display is organized in this way. Here I have shown a 7 segment LED display. You can see here 1, 2, 3, 4, 5, 6, 7. 7 segments are there apart from this decimal point. Let me draw it. So it is organized in this manner: one segment, another segment, another segment, another segment, another segment, another segment, another segment, and a decimal point. And these are numbered as, say, this is A, segment A, segment B, segment C, segment D, segment E, segment F, segment G, and this is your decimal point. Now, the 7 segment LED is packaged. If you, this is the LED display as it is shown. Now, the IC, this particular package is available. As you can see, 8 pins are there, not 8, 5 plus 5, 10 pins are there. You have to make use of these 10 pins so that you can use any one of these segments. Essentially, each segment represents one light emitting diode. So, inside the device, the connection is somewhat like this. Say you have 8 LEDs, 7 plus decimal point. So, 8 LEDs are here. 8 light emitting diodes are here, and usually either all the cathodes are tied together and available as a single point. So, you have got say A, B, then this is your decimal point. So, 8 segments, 8 anodes are available here, and the common cathode is available here. This is common cathode type. So, in such a case, you can see that all the segments are, all the LEDs are separately available with separate anode lines and a common cathode line. The LED display can be also available in another form, in which case it will have, say, all the anodes are tied together. Say this is one LED. Let me use the red pen. So, this is one LED, this is another LED. So, these cathodes are separately available, but the anodes are tied together and available as a single pin. So, in such a case, the particular package will give you these lines, this common line and these cathode lines, separate cathode lines, and this is known as common anode. Common anode type. So, LED displays in 7 segment form are available in common cathode form or common anode form. So, and this you have to interface to the microprocessor and display information. What kind of display you can get from this? This is shown with the help of this diagram. You can represent all the hex characters with the help of these 7 segment displays. I have not shown the decimal point, but as you can see here, this is one LED, and you can, I have displayed 0. To display 0, this segment, this A, B, C, D, E and F, these segments are to be you have to pass current through these LEDs, light emitting diodes, so that the display is for 0. Similarly, in this case, you have to use only the segment B and C. You have to pass current through the diodes corresponding to B and C segments. So, in this way, as you can see, 0, 1, 2, 3, 4, 5 up to F, A, B, C, D, E, F, all the hex characters can be displayed with the help of 7 segments. So, the 7 segment LEDs can be used, as you can see, not only the decimal numbers, but the hex characters like A, B, C, D, E, F, including 0 to 9. And in most of the simple equipments, these hex characters are used to display the information to the user. Let us see how you can use uh, these 7 segment LEDs to display significant information or reasonable amount of information. Obviously, a single 7 segment display can display one character, but usually one character is not sufficient. You have to interface several characters. How it can be done? Let me explain here. I shall take help of the port lines. Now, let us assume we have 6 light emitting diodes to be interfaced to the microprocessor, and here are the 6 light emitting diodes, 7 segment LEDs. These are the 6 LEDs, 4, 5. Now, let us assume this is a display module, and interconnection is made in such a way that you get all the 6 segment lines tied together, 1, 2, 3, 4, 5, 6, 7 and 8. These are those lines which I have shown as A, B, C, D, E, F, G and then the decimal point. For all these digits, all these light emitting diodes, all the A's are tied together and available as a single line. All the B's are tied together and available as a single line, and these are the common cathodes of each of these segments, each of these digits. So 6 digit, for 6 digit you will get 6 common cathodes. So here we have used common cathode type. Obviously the circuit will be different if the LEDs are of common anode type. Now what we do, we make the interconnection like this. Say from port A we use a transistor driver the way we made earlier, and the resistors are here and it is connected to, let us assume it goes to the decimal point, and we will require 8 such transistor drivers getting connected to PA0 to, let us assume, PA7 line, and here is the 8th transistor and it is connected to this line A. So here with the help of 8 transistors and a number of resistors, the resistor values are to be calculated the way I have shown, and the collector current will correspond to this particular current, and the base current of this transistor has to be decided based on the gain of this. So the collector current by the gain of this transistor will decide this resistance. So this is the base resistor and say collector resistor RC, and 8 such transistors along with 16 resistors are required to drive the segments of these 8 segments of the 6 displays. Now we will also require some transistors to connect to these common cathodes. So here is one common cathode, and you will also require say PB0 to PB7. We are using the port line B port for this purpose, and this is connected to common cathode of this, and this is connected to common cathode of the last digit, and obviously you will require 6 such port lines. So 0 since 6 are there, 0, 1, 2, 4, 5, 7 up to 7 will not be required. Now let us see how it really works. What will be done? First you output the corresponding code. Say you want to display B, to display say display 1, to display 1 segment B and C are to emit light. So in such a case what you have to out, so as we know that this line will be whenever this line is 0, light is emitted. That means the output, corresponding output that will be you have to generate here will be 1 0 0 1 1 1 1 1 to display 1. Now how the display on this digit or on this digit or on which digit it will take place, that will depend upon which particular transistor has been turned on here. Let us assume you want to display here, then you have to output the code as I told, you have to output, you have to display, if you want to display 1 here, you have to output 1 0 0 1 1 1 1 1, because B and C are to glow. So, that means this is A, B, C, D, F, G and decimal point. And to make this line low, to glow this particular device, you have to make this particular transistor 0, so that the current will be drawn. So, you have to output 0 1 1 1 1. So, if you output on port line 1 0 0 1 1 1 1 and then 0 1 1 1 1, it will display 1. In a similar way, you can select any one of these digits and you can display on any one of these devices. Now, you may be asking, how do we get the display on all these 6 segments, on the 6 digits? How do we get that? We have to make use of the property of the retentivity of I, which is the basis of the cinema, which is the basis of the TVs. If you display this one, then this one, then this one, then this one, then this one, this one repeatedly at a at say beyond certain rate, then it will appear as if you are getting a steady display on these displays, on all these digits. So, you will get steady display on all these digits if the selection of each of the digit is done very quickly, and because of the retentivity of the eye, you will get a steady display on all these lines. In other words, you will be scanning the digits or refreshing all the digits. You can say, you can use the term scanning or refreshing, either of the term is used. So, you have to refresh at regular interval continuously, you have to select this particular digit and output corresponding information to display some value and so on. So, in this way you can interface 6 digit on the light emitting diode, 6 digits, 7 segment digits to a microprocessor by using 2 port lines. We have seen that. Now, just like the keyboard module I had shown in the last lecture, you can also use a display module, and display module can be realized in this manner. So, this is the 6 digit display module. Let me explain the operation of the 6 digit display module. Here there are 6 digits, 6 LED segments, 6 digits. So, FND 500 common cathode type. So, this is the common cathode type displays. 6 such digits are shown here. This is 1 digit in this way. This is the 6 digit. 6 digits are there. Now, what has been done, instead of transistors, we have used some special type of ICs which are available in the market, especially designed for this purpose. This 75491 is known as segment driver. As you can see here, it has got 4 input lines and 4 output lines, and you have got for each of these segments there is a Darlington pair of transistor. Instead of 1 transistor, there is a Darlington pair of transistor, and it is connected in this way. This base is connected here, and this is connected to this line, and the emitters are grounded. If you connect it in this way, then each of these digits can be displayed. That means, whenever this line is 0, then this transistor will be off, but whenever this output is 1, say this is 1, then this current will flow through the base, and this transistor will be on, and 0, that means 0 will go and you will not get any display. On the other hand, if this output is 0, then this transistor is off, and this current will flow through the light emitting diode. So, this is the operation of each of these Darlington pairs, and you have got 4 such pairs inside each chip. So, you will require 2 75491 to interface to 8 segments. As you know, A, B, C, D in this way up to DP, 8 segments are there. So, to drive 8 segments, you will require 2 ICs. Of course, you will require the necessary resistors. So, you see the base resistor value is 3.9 K, and the resistor that is used to drive the LEDs for getting necessary intensity of light is 150 ohm. Now, these are the segment drivers, and here there is another transistor, another IC where you have got 8 Darlington pairs, 1, 2, 3, 4, 5, 6, 6 Darlington pairs, and you can see here these transistors are connected, and you can use it to connect to each of these digits. So, this is known as digit driver. So, these two are this 75491 is segment driver IC, and this is digit driver IC, and with the help of this digit driver IC you can sync the current from each of these segments whenever you have to display a particular digit. So, you can display this digit or this digit, and can select this, and obviously by programming these ports, port B and port C, you can do the necessary interfacing to this display module, and display module is shown here. We have realized it. The circuit diagram which I have shown, the same display module is shown here. Here you see we have got 6 digit, 6 light emitting 7 segment displays, and these are the this is your digit driver 75492 and 75491. These are the segment drivers, and these are the resistors that I have shown, and through this connector you can connect it to the port lines. Here you have put a connector which you can connect to the port line, and this goes to the power supply line plus 5 to and ground. So, this is how you can realize you can implement a microprocessor based system in modular form. In the last lecture I have explained the operation of a keyboard module, and this is the light emitting diode module. So, this keyboard module and light emitting diode module can be interfaced to the microprocessor kit or microprocessor along with RAM and ROM to make a complete system. Now, after discussing the 6 digit display module, let us conceive whether we can interface both the LEDs and the keyboard together to form a display as well as keyboard module. With the help of LEDs you will display the information, microprocessor will display the response, and with the help of the keyboard the input can be taken, and that can be done and by using the interfacing together the displays, as well as here is a 6 by 6 keyboard and here is 6 7 segment LED displays. Let us see how it can be done. Now, let us assume this is your port A, PA0 to 7, and this is connected to segment drivers. As I have already explained what is segment driver, you will require this kind of circuit, this kind of segment drivers, and 2 such segment drivers will be required that will go to various segments of the 6 segment digits, that means A to decimal point. And these are the common cathodes of the 6 digits that we will get here. I remember it is 7, so 6 digits. So, these are the 6 cathodes. So, and you will require common cathode driver. Now, we have seen that to get the data from a keyboard, you have to scan the keyboard, and to display the data continuously, you will also have to scan the light emitting diodes. Why not do it together? We can use common keyboard scanning as well as display scanning, and that is being done in this particular circuit diagram. So, here you see it goes to both. So, this is a common scanning technique, and here it does the display scan. The same lines can be used to perform keyboard scan. And the as you have seen, the outputs from the keyboard, those column lines, this will go to the row lines. You can use decoder if necessary here, and this will go to the column lines. So these lines can come from PB. So you will require 6 digits. So that means here 0 to 5, and this can come to PC. Here also you will require 6 lines, so 0 to 5. So by using 3 ports, you can see here you can interface 7 segment LED displays. You can also interface 6 by 6 keyboard, and you can write a program in such a way that it will do the display as well as scanning of the keyboard together. You have to write proper program for that purpose. Now in this particular case, whenever you do it with the help of the port lines, interface the LEDs and the keyboard through port lines, obviously everything is controlled by a program. So whenever you want to display something, or you have to read the keyboard, scan the keyboard, you have to run the run a program. So your microprocessor will remain busy for this mundane job, just for scanning the keyboard and display something. How it can be overcome? This can be overcome with the help of a special type of device known as 8279 programmable keyboard display interface, a special purpose. Earlier we have discussed a general purpose programmable peripheral interface 8255. Now we have the Intel has developed a special purpose programmable peripheral interface which can be used for interfacing keyboard and display. This is 8279. 8279 programmable keyboard display interface. So in this keyboard display interface, let us see what are the different functions it has got. It has basically got 4 different sections. First of all, it has got the microprocessor side, microprocessor section. By microprocessor section, I mean you can see here on this side the signal lines are available in such a way that it can be readily interfaced, particularly to Intel series of microprocessors, to 8085, 8086 and so on. The way the signals are available from this microprocessor, here the signals are available in the same form. So on the microprocessor section side, you find that data lines, read, write, then interrupt, this can go to any one of the interrupt lines, then the chip select, the CD command or data can come from one of the address lines, then reset line, clock line, these are generated by the 8085 microprocessor. So this microprocessor section will be interfaced to this side, so this side will go to microprocessor. Of course, you have to use some device decoder circuit to generate this chip select, so that various resistors, as I shall explain, are mapped on the IO address space. So this is the microprocessor section. Then it has got the keyboard section. In the keyboard section, as you can see, there are 8 lines R0 to 7, then shift and control. So these lines are essentially the column lines coming from the keyboard, and this keyboard can allow up to 8 by 8 keyboard, that means 64 keys can be interfaced very easily through this particular programmable keyboard display interface. So these lines are coming from the column lines. So 8 column lines are connected here. Then it has got 2 additional lines, shift, then control and strobe STB. These lines are also coming from the keyboard, and essentially with the help of these lines you can shift the keyboard data and control register, and the information that is being sent from here are stored in 8 registers in a 8 by 8 FIFO sensor RAM, first in first out sensor RAM. That means you can enter 8 keyboard information and which will be stored here. If you remember, we discussed about the technique of n key rollover and 2 key lockout. So both are allowed here, that means both are permitted here, and whenever you are using the n key rollover, then the information about 8 key depression can be stored in this 8 by 8 FIFO sensor RAM, and from this 8 by 8 FIFO sensor RAM, whenever there is some data in this FIFO sensor RAM, it will generate an interrupt. So the information stored in this FIFO sensor RAM, first in first out, the way the keys have been depressed, that accordingly one after the other the information will be passed on through the data lines to the microprocessor, and that will be done by using a interrupt driven mode. So interrupt will be generated as long as there is some data in this FIFO sensor RAM. The FIFO sensor RAM will hold 8 bit data, out of which 6 bit is for the row and column information, and 2 bit are available from shift and control stops information. So these 2 bits along with 6 bits for row and column information are stored here, and that goes one after the other to the microprocessor. Then you have got the scan section. Scan section is for common keyboard and display scanning. As you can see here, you have got 4 lines. So these 4 lines obviously is not sufficient to interface to say 16 digit display or 8 by 8 keyboard. So what you have to do, you have to use decoder. This will go to a decoder, as we have shown earlier in our circuit, that you can use some decoder, and then decoded output for keyboard interfacing. I have explained how the decoders can be used. So these 4 lines will go to the decoder to generate 16 lines for interfacing the keyboard as well as the display. Display will also require decoder to interface 16 by 8 display RAM. So this is the scan section, and then you have got the display section. In the display section, as you can see here, there are 4 plus 4 8 lines and 1 BD line. This is your this BD line is used for displaying purpose. This is used to blank the display. BD is used, it stands for blank display. Whenever you want to blank the display, this can be used. And these lines A0 to 3 and B0 to 3, these lines are used in groups of 8 bits or 2 4-bit groups. 2 4-bit groups. You can use it in any one of these forms, and this is going to the displays. So you can use these lines for driving the segments, as you have shown that these lines are used for segment drivers. So 8 lines are necessary to drive each of these segments. So A0 to 3 and B0 to 3 together forms the 8 lines, and with the help of these 8 lines you will be able to display those 8 interface to these 8 segments. As you have seen, you require 8 lines to drive 8 segments. So these lines are forming that, and the inputs are coming to these lines. That means in case of keyboard, these inputs PC0 to 5, and if you have got 8 by 8 keyboard, then you will require obviously the 8 lines, and these lines are forming those 8 lines, and the display information can be stored here. So you can see 16 by 8 resistors, 16 by 8, that means 8 bit 16 resistors of 8 bit are available as display RAM. The information you want to display on 16 digits can be stored here. So it can be used to store the information of 16 digits. Now how it really works? If you want to display something on 16 digits, with the help of these control resistors, which can be selected by this C and CD, that means command, whenever this line is 1, then this control register can be accessed, and it has got many modes, and with the help of which you can access these, you can program to access these display registers, and you can store the information you want to display on these 16 digits. And after you have programmed, initialize the mode of operation and store the information of 16 digits, it will run on its own. The microprocessor will be free. You do not have to run a program to display some information on the LEDs or scan the keyboard. This particular device, this programmable keyboard display interface, will keep on scanning the display as well as keep on scanning the keyboard, and whenever there is any key depression, that will be transferred to this FIFO sensor RAM, and it will interrupt the microprocessor through these interrupt lines. It can be connected to one of the interrupt lines and the display will take place. So, this is how it will work. Let us see how it can be interfaced to the 8085. So, as I have explained, this is the MUP side, MUP section, microprocessor section. It has been directly interfaced to 8085, the data line, read, write. Then A8 is connected to command data line. That means when this bit is 1, you can select that control register, and whenever this line is 0, then you can access any one of these display registers, or you can access this FIFO sensor RAM, and that can be programmed by write some code into that control register. And this is that interrupt line which has been connected to RST 7.5, and the set line has come here, clock line has come here, and A9 to A15, actually A9 to A8 to A15 has been used for I/O. With the help of this device decoder circuit, you have to map these registers on the I/O address space, and this device decoder circuit will do that, and whenever this is 1 and proper values are used, this chip will be selected and you can access various registers inside the chip. And you can see here those scan section lines, scan lines 0 to 4 have been used with the help of suitable decoders. So, here I have used 8 by 8 keyboard, so 3 to 8 decoder is necessary. On the other hand, 16 7 segment LED displays are here, you will require 4 to 16 decoder. So, this there is a scan register inside this 8279 chip, and that scan, with the help of these scan lines, I mean that scan register, it will keep on scanning. Initially it will output 0000, then 0001 and so on. It will keep on scanning, and the display will be made, and also keyboard will be scanned, and decoder outputs are generating signals to select different digits of the displays, and here also select different rows of the keyboard. So, the scan lines are performing the row scanning as well as the digit scanning that is necessary for steady display as well as for continuous scanning of the keyboard. So, these two are done together, and then whatever information is to be displayed are displayed here, and whenever there is a keyboard depression, that is that goes to the 8279 and the to that FIFO sensor RAM. As I explained, that FIFO sensor RAM holds that information, and as long as it is not empty, it will keep on generating interrupt, and then the microprocessor will jump to interrupt service subroutine and will perform the necessary action. So, this is how this particular 8279 device works. Although LED displays are very popular, in recent times another types of display devices known as liquid crystal displays are becoming more and more popular. Let us see why liquid crystal displays or LCDs, as they are popularly known, are becoming more and more popular. First reason is proliferation of portable equipment. In recent times, many portable equipments are gradually being used, like cell phones, PDAs and so on, which are battery operated. And in battery operated devices, the battery life between two charging is very important. So, in such a case the display device should consume very small power, and in that context liquid crystal displays are very useful because they consume much smaller power than light emitting diodes. So, because of the proliferation of portable equipment, LCD displays are becoming more and more popular. Second is declining prices. Earlier the cost of liquid crystal displays were very high, but in recent times the cost of LCD displays, liquid crystal displays are going down because of widespread use. Larger the volume of cell, lower is the cost, and that is happening, the cost is increasing. And another important advantage of LCD display is, apart from displaying numbers, it can display characters, say A to Z, apart from 0 to 9, and it can also display graphics. You may have seen the LED displays used in cell phones can be used for playing games. So, where the graphics display is used. So, LCD displays can be used for character display, all the alphanumeric characters can be displayed, and graphical images can also be displayed. Then another important advantage of liquid crystal displays is that the refresh controller can be built in as part of the display module. You do not require a separate programmable device like 8279 for interfacing the LCDs. The refresh controller can be built in as part of the display device. And finally, the ease of programming. Programming is also simplified in such cases. So, let us have a look at a popular or a typical LCD display, intelligent LED display. It requires supply voltage, ground, and another voltage which for controlling the intensity, and it provides you two rows of display, one row and another row. So, usually two rows of display are possible, and in each row, so this is your row 1 and this is your row 2, and each row you can display 20 or 40 characters. 20 to 40 characters can be displayed on each row, and this side, these lines D0 to D7, RS, register select, read write, enable, these lines can be connected to the port lines of the microprocessor or the programmable IO port, say 8255. So, this is the typical display module schematic diagram. Let us see what is inside an intelligent LCD display. Inside there is a command register with the help of which the various modes of operation can be programmed, and there is a display RAM which holds the information you want to display on these character lines, or if you want to display some graphics, that information is stored in this display RAM. And here it shows how it is interfaced to the through a port line. So, it can be 8255, a general purpose programmable peripheral interface, and say port A is connected to D0 to D7 lines, these lines, and port C, 3 port C lines, PC0, PC1 and PC2, these lines are connected to register select, read write and enable line. And as you can see here, supply voltage is 5 volt, you do not require high voltage, and this VE can be used for controlling the intensity. Now, what you can do instead of using -5 volt, you can put a resistor here, this side can be grounded and this side can be connected to say VCC, and by changing the potentiometer you can control the intensity of the display. And this is how you can perform the read write operation in any one of these registers, command register or display registers. Obviously, read write is not a very fast process, the device is not compatible in speed with the microprocessor. So, this is the typical timing diagrams. For example, you generate the read write signal. So for writing, this has to be low, and you then make the register select line high, low, this RS. And as you can see here, after you generate the register select, there is a address setup time which is typically 140 nanosecond, and after that you will generate that enable signal, and you have to keep that signal for 450 nanosecond, so that the chip is enabled and reading and writing is possible. So 450 nanosecond is necessary for that purpose. Then you will require address hold time for another 10 second, and this is the data time, and you have to set up the data for at least 195 nanosecond. So these are the minimum times that you require for programming. Obviously, these timings can be little longer for proper writing inside the device. And what are the various control registers are present? Let me explain that with the help of these registers. So these are the command codes. You can select various operations by writing different codes into the register. So that data what you want to write can be passed on with the help of these port lines. If the RS line is 0 and read write is 0, then you are performing write operation, and if the 01 is the code in hex, then it clears the LCD and memory home, clears the LCD and memory, and there is a cursor on the display. You will get a cursor. So the cursor can be in any position. So the cursor position can be home, means it will go to the first position, or it can be positioned to any one of these display lines, and that can be performed with the help of this command. Then there is another command, home cursor only. It does not clear the LED or memory. The corresponding code is 02. That means if you write this code into the command register, then this cursor will go to the home position. Then 04 is for the decrementing the cursor, shift cursor to the left. Suppose the cursor is on a particular character, so it will go to the left direction. If you execute this instruction, if you write this particular word into the command register, or it will go to the right position, increment the cursor if you write this code 006. So in this way you can shift the display right by writing 05, you can shift the display left by writing 07 into the command register. You can perform display of the display the cursor off, display off and cursor off by writing 08, display off cursor on by writing 0A, display on cursor off by writing 0C. If you write 0E, then it is display on cursor blinking. Cursor can be blinking as well. And also you can perform shift cursor position to left or right by writing either 10 or 14. Shift the entire display to the left or right by writing 18 or 1C. So these are some of the typical comments that is provided in these intelligent display LCD display devices. You can also write into the data registers with the help of by writing some value. Say if D7 is 1, then 0, then by providing the address in the remaining bits, you can write data in the display RAM, either in the line 1 or in the line 2 by writing this value. Then if you execute that write operation, it will go to the display RAM. That means the address of the display position can be provided here either for line 1 or line 2. After executing this command word, then if you write another data, it will go to the display RAM, which is provided here. So in this way the display RAM values can be written, and after that it will keep on displaying on the display devices. So you can see the interfacing is very easy. Interfacing is very easy, and by using a one port and few lines of port C, you can do the interfacing, and you can write the display RAM and you can with the help of suitable comment register, and once it is done it will keep on displaying and all the refreshing and everything will take place automatically. The microprocessor will remain free. So friends, in this lecture we have discussed the interfacing of the most popular display device, that is the light emitting diode, particularly 7 segment LED displays, how it can be done with the help of this programmable special purpose interface controller, LED controller, and also we have discussed the interfacing of an intelligent LCD display, which are becoming more and more popular in recent times. In the next lecture, we shall discuss about some more special purpose devices which are used for interruption and DMA mode of data transfer. Thank you.